In this problem, we're going to convert another rate. We are taking care of a client who starts to experience frequent ventricular dysrhythmias. The physician orders an infusion of lidocaine at 2 milligrams per minute. The lidocaine is supplied in terms of 2 grams every 250 milliliters. What is the infusion rate in milliliters per hour? In this problem, I'm going to use dimensional analysis. I'm going to do that because this is a multiple step problem. Using a proportion method, we would have to do multiple proportions. And if we had numbers where we had to round, we could see that we would actually experience what's called a rounding error in our answer. So because this is going to be multiple steps and dimensional analysis is made for multiple steps, that's what we're going to stick with. Remember, a good place to start with dimensional analysis is what's ordered. Think about what's ordered and what our answer needs to be in, and how might we be able to get there. So if you first think about it, we're going to be starting with something here, and then when we're done with dimensional analysis, think about the unit that we want. Well, we're asked to find milliliters per hour, so we better have, when we are done with our dimensional analysis, milliliters in the numerator, an hour in the denominator. What we're starting with, what is the order? It says here that the physician orders an infusion of lidocaine at 2 milligrams per minute. So that is the order. So we have 2 milligrams for every 1 minute. What we want to do is to somehow cancel out milligrams to get milliliters, and we want to somehow cancel out minutes to get hours. When we're done with our dimensional analysis, that's what we're hoping for. It may be a little bit easier to start with minutes to hours, or you could start with milligrams to milliliters. It doesn't matter. Since we know the number of minutes in an hour, maybe we could just start there. So if I'm going to be converting, I want to cancel out minutes. Notice minutes is in the denominator of our first expression here, our first ratio. So in order to cancel it out using our conversion factor, we need to have it in the opposite side of the fraction here. So minutes needs to cancel out, so minutes will be in the numerator. And in the denominator, we're going from minutes to hours. And what we're told, actually what we know, is there are 60 minutes and 1 hour. Notice if I were to stop right now, minutes would cancel, and I would have hours in the denominator. I'm going to circle that hours because that's the unit we want at the end. So I'm just going to circle that to remind myself that I don't need to change that now. That is exactly what we want. Now what we need to do is to multiply by a few more conversion factors in order to get milliliters. I need to cancel out milligrams. So I know that that's going to be in the denominator because in our first expression, milligrams is in the numerator. So in this conversion factor, milligrams will be in the denominator to cancel it. What we would love to do is to just go from milligrams directly into milliliters. The problem is we don't have and we don't know a direct conversion from milligrams to milliliters. Usually that's given to us in what's available or the concentration, but if you look at what's supplied, what's available to us, this is in grams per milliliter. So instead of going from milligrams directly into milliliters, what we can do instead is convert milligrams to grams, right? Because we can go from one unit to another quite quickly using dimensional analysis. Again, the reason I'm doing this, I need milliliters at the end, but in order to determine the number of milliliters, I need to know the number of grams. I need to have grams. So I'm going to change milligrams into grams. This can be done because we know 1 gram is 1,000 milligrams. That's just our knowledge of the metric system. If I were to stop right now, milligrams would cancel. I would have grams in the numerator and hours in the denominator. That's not what I want. So what I can do is I can immediately now cancel out grams and go from grams into the milliliters that I want. And that's what's supplied. That's the order, or excuse me, that's what's supplied to us, that's what's available. The conversion factor here, 2 grams, is going to be equivalent to 250 milliliters of this solution. If I were to stop after this step, grams would cancel, and I have milliliters. If you notice, if we were to stop right now, in the numerator our unit would be milliliters, in the denominator our unit would be hours. That's exactly what I want. So I'm going to stop with my dimensional analysis and proceed with the multiplication of all the numerators. So I'll have 2 times 60. 2 times 60 times 250. What I get is 30,000. So I'm just going to write 30,000. And my unit is milliliters. In the denominator, 1 times 1 times 1,000 times 2, well, that's just 2,000. And my unit is hours. Now, I just need to divide 30,000 divided by 2,000. I get 15. 15, and this is milliliters per hour. That is the solution to this problem. 15 milliliters per hour. Again, when we are using dimensional analysis, we start with what's ordered. In this case, we were ordered 2 milligrams per minute. Even before I started doing my calculations, I did a little mapping out of what I'll need to do. I'll need to have my answer in milliliters per hour. So can I convert milligrams into milliliters? Sure. But I first had to, convert it into grams and then milliliters. And actually, the first thing we did was convert minutes to hours. It doesn't matter if you do the minutes to hours at the end or in the beginning. Notice it would still be in the same spot. The trick here is knowing that we can't go directly from milligrams to milliliters unless we do some sort of conversion.